Okay, so in this very short video, we're just going to introduce the next unit, which is Unit 5 over circular motion. This unit is basically going to be an extension of the Newton's laws of motion unit, which we obviously just finished. So basically, the study of circular motion is exactly what it sounds like. It studies objects that move in circles. Okay, so for example, planets orbiting the sun, or moons orbiting different planets, race cars driving around a track, roller coaster rides, going upside down, and all kinds of craziness in between. Okay, so anytime an object moves in any type of non-straight line, think circular motion. So this unit is going to be super short. There's only going to be a few new concepts and equations, and so make sure you're paying really close attention, taking good notes, and asking questions when you need clarification. Okay, so we're only going to do rotation and revolution in this video. So let's talk about some definitions of things. Okay, so first of all, I want to define what's called uniform circular motion. And so an object is said to be in uniform circular motion when it is changing directions with constant speed. Okay, so let me show you an example. Okay, so this would be an example of uniform circular motion. You can see a ball, the ball is going around in a circle, and the speed is not changing. It's not going any faster or slower, but it is changing direction. And just to show you what that looks like, you can see here the blue arrow represents the velocity of the ball. And you can see, even though it's not going any faster or slower, you can see the direction of the arrow is clearly changing as it goes around. Okay, and so this is an example of uniform circular motion. Now, the key concept here is that because the velocity is not constant, the object is accelerating. And you might think, wait, but it's not going any faster or slower because you said constant speed. And that's correct. So this is an example of an object accelerating without speeding up or slowing down. And the reason that's possible is because velocity has direction. Okay, remember that's one of the key differences between velocity and speed. Velocity has direction and speed does not. And so even though it's not moving any faster, the velocity is still actually changing because the direction part is changing. Therefore, an object in uniform circular motion is in fact accelerating. Again, we'll talk more about that in the next video, but that's one of the key concepts in this unit. Okay, so objects moving in uniform circular motion are accelerating because their velocity is changing direction. Okay, so that's the key concept of this whole unit. We'll come back to that in the next video though. What I want to talk about in this video is the difference between a rotation and a revolution. And so they both involve objects kind of moving in some type of circular motion, but there's a key difference between the two. Okay, so here's the difference. It all has to do with where is the center of the circle relative to the object that you're talking about. Okay, a rotation is a situation where you have the center of the circle inside the object itself. For example, if you take a basketball and you spin a basketball on your finger or you spin it on the ground, the center of the circle is inside the basketball itself. Okay, therefore that is an example of a rotation. The ball is rotating as it spins around. In a revolution, the center of the circle is outside the object. And so an example of that would be tetherball. And if you don't know what tetherball is or never played tetherball, I can show you a quick clip. So I will link that tetherball clip, and then after that, you can understand why it's an example of a revolution. Okay, so in the tetherball clip, hopefully you saw that the ball is the object. The center of the circle is the pole, because that's where it's moving around the pole. And so the pole is not inside the ball, it's outside the ball, and therefore that is an example of a revolution because the center of the circle is not inside the object itself. Okay, so that's the difference between a rotation and a revolution. It has to do with, is the center of the circle inside the object or outside the object? So let's take a look at some more examples. It says label the following as being either a rotation or a revolution. Okay, so a hula hoop. So imagine using a hula hoop and spinning around the hula hoop. Is that an example of a rotation or a revolution? Well, the center of the circle would be your body, which is not inside the hula hoop itself. And so that would actually be an example of a revolution. Okay, because if you think about the actual physical hula hoop itself, it's wrapped around your body. Your body is basically the center of the circle, but that's not inside the hoop itself physically. Okay, so that is an example of a revolution. What about when you open a bottle of soda? Think about when you twist the lid. As that lid moves in a circle, is that a rotation or a revolution? Well, the center of the circle is right here in the center of the lid. That is inside the object. Therefore, that is an example of a rotation. The bottle, the lid of the bottle is rotating as you twist it. Okay, so think about this third example, a merry-go-round. You see these on playgrounds all the time. Is that an example of a rotation or a revolution? Again, it comes down to where is the center of the circle. Here, the center of the circle is the middle of the merry-go-round. Because the center of the circle is inside the object, this counts as a rotation. Okay, there's the center, it's physically inside the merry-go-round, therefore the merry-go-round is rotating as it spins around. And then finally we have the moon orbiting the Earth. This is an example of a revolution. The reason is basically if you have the Earth, let's say you have the moon out here, going around in a circle, something like this. It's a bad circle, but just bear with me. Think about where is the center of the circle. The center of the circle is inside the Earth, over here. That is not inside the moon. Okay, if the center of the circle is outside the object itself, it's a revolution. Okay, so here we would say the moon is revolving around the Earth. Okay, so make sure you understand the difference between rotation and revolution. And just to show you one more quick slide with some examples. Here you can see the Earth itself is actually rotating and revolving. So another example of rotation is as the Earth spins on its axis. That is an example of a rotation because the center of the circle is inside the Earth, and the Earth is what's moving. So the Earth is rotating about its axis. Okay, and remember the time it takes to complete one full rotation around its axis, that's called a day. The Earth also revolves around the Sun, and I know this picture is a picture of the moon revolving around the Earth, but you can also imagine the Earth revolving around the Sun, because as the Earth goes around the Sun, the center of the circle is inside the Sun, okay, which is outside the object that we're talking about, which is the Earth, which is why that is a revolution. So the Earth not only rotates on its axis, but it also revolves around the Sun. Okay, so make sure you understand the difference between rotation and revolution. So in the next video, we're going to talk more about that changing velocity for objects in uniform circular motion. And then we'll do some calculations with that. As always, please let me know if you have any questions, and I'll see you guys in the next video.